This is chapter 17. I believe it's section 5 on stress and adaptation. And what we're going to be looking at is what is stress from a physiological point of view, and how does the body respond. And the body has a general response to stress, and we're going to be looking at that and how it's coordinated. All right, so let's get started, shall we? First and foremost, we have to define stress. Stress is caused by any situation that upsets homeostasis and threatens one's physical or emotional well-being. So, let's write that, huh? How about I pick up a pen, shall we? Okay, so, caused by any situation that upsets homeostasis, homeostasis, and threatens one's physical and this is an AO and or emotional well-being. So that's what stress is, and that's a very, very broad definition. Okay. So, what could fall under this category? Well, physical things: injury, surgery, infection, intense exercise, pain, grief, depression, anger, etc. So, very, very broad definition. And the body has what it's called a general adaptation syndrome, and it is a consistent way the body reacts to stress. Okay? So, and it's going to involve both parts of our adrenal gland. Okay? Occurs in 3 stages: the alarm reaction, the stage of resistance, and the stage of exhaustion. So let's look at what happens. So, something happens, and you are under stress. I'm skipping this. Doesn't matter because I'm not going to put it. So let's look. What is going to happen? So, I like the alarm. I like this picture that I gave you in the notes a little bit better. It's much, I like how it's done. But, so we're going to have an immediate short-term response to a crisis. Yeah. And it's going to be mediated by norepinephrine from the sympathetic nervous system and epinephrine from the adrenal medulla. And we're talking about this preparation of fight or flight. Okay? So what's going to happen? Let's look at the changes. We are going to get increased mental alertness, increased energy used by all cells, we're going to get mobilization of our reserves, so glycogen and lipids. We're going to get changes in circulation. We're going to see increased heart rate, increased blood pressure. Okay? We're going to get reduction in digestive activity and urine production. We're going to get increased sweat and increased heart and respiratory rates. Why heart and respiratory? Well, because we're trying to make sure that the tissues have enough, the brain and the muscles really, have enough energy and oxygen to get away from whatever it is that's causing the stress. So what's going to happen is stress is going to hit the brain. And short-term stress, what you'll get is a nerve impulse that gets communicated to the adrenal medulla, and that's going to secrete epinephrine. At the same time, that stress, if it's kind of more prolonged, is going to also stimulate the release of ACTH and stimulate the adrenal cortex. Okay, so in the long term, we're going to get some other things happening. And let's take a look at that. So the alarm reaction is our initial response. Where does the signal come from? Well, it's going to be mediated by norepinephrine. Norepinephrine, and this is from the sympathetic nervous system. And epinephrine. And this is going to be produced by our friend, the adrenal medulla. And really what these are doing is preparing the body for fight or flight. Okay. And in the process, one of the things it's going to do is increase aldosterone and angiotensin levels. Why? Well, we got two things going on. Angiotensin, is a very, very potent vasoconstrictor. And what this leads to is increased blood pressure. Aldosterone over here is going to retain sodium and water. So what we're doing when we do this is we're maintaining blood pressure and blood volume. Remember we talked about this in the last lecture. So that's really what's going on with our alarm reaction. We're getting prepared. Now, after a few hours, glycogen reserves are gone, but brain still needs glucose. So what do we do? Well, we're going to look at alternative fuels. And this stage, and alternative fuels are lipids and protein. Okay. And what hormone is going to dominate? Well, that's cortisol. And this is going to have a number of effects. So, we're going to see a lot of things going down, right? Increased gluconeogenesis. We are going to, and this, by the way, is primarily amino acids. We are also going to see a hyperglycemia because the glucose is being conserved or spared for the brain. We're going to see increased protein breakdown, particularly muscle. And what we're really talking about is muscle. And we're going to have increased fat metabolism. So we're going to break down our fats so we can use them for fuel. And we're going to decrease our calcium absorption from the gut. That's going to slow down metabolism. And that's the effects. And that's what's going on in this stage of resistance. And because this stage is dominated by cortisol, we're going to see all the wonderful things that cortisol does, including some anti-inflammatory effects. And if it's prolonged stress, we may even get to the point of immunosuppression. So, cortisol has what we call, I just said all this, but here's the place where I actually meant to write it. Got my notes. Okay. And I have a dog in here who's like, okay, so cortisol has our glucose-sparing effect. Okay, so it's going to inhibit protein synthesis. So free amino acids go for gluconeogenesis. But we have some problems. So the problems that we're going to have with excessive cortisol is it's going to depress immune function. It's also going to increase susceptibility to infection and ulcers. And we're going to get atrophy, and our lymphoid tissues will atrophy. Also, if it's prolonged enough, we're going to end up eventually breaking down our muscle. And we'll get weak, okay? Because if we look back here, right? Increased gluconeogenesis, hyperglycemia, increased protein breakdown, particularly muscle, increased fat metabolism. So we're also going to have some other issues going on. And let's have a look. I found this graph. I was trolling the internet, and I found this graph, and I thought it was really neat. So, this is a graph of something called adrenal fatigue syndrome and how it goes. Okay, so this is what happens when you're under a prolonged stress. When stress continues for several months and fat reserves are gone, homeostasis is overwhelmed. And what you see is marked by a rapid decline in death. That's over here. This is adrenal failure. Right, that's over here. Okay. And you're going to see protein breakdown and muscle wasting. You are going to see, as you get to the end, a loss of glucose homeostasis because your adrenal gland is no longer able to produce cortisol. Okay. Next, aldosterone is going to promote water retention and hypertension. So you're going to have lots of sodium, and you're going to be dumping potassium and hydrogen ions in the urine. So you get hypokalemia and alkalosis, which are going to affect all your body tissues, and hyperkalemia your heart. And death is going to result from heart and kidney infection or overwhelming infection. But this is not necessarily a fast process. It takes time. And it doesn't happen all in one downhill slope. Okay? So, alarm response that can last for years. Stage 1. First symptomatic crash with unbearable symptoms is the crash penetrated the adrenal system's threshold. Hypoglycemia, fatigue, insomnia, irritability, and anxiety are common. That's what 2 is. 3 were symptomatic. This is entering stage 2 of adrenal fatigue. This is the resistance response. So down here at 3 is the resistance response. But notice, you kind of, what seems to be experienced is that you sort of recover, and then it doesn't go down in a straight line necessarily. So you recover, but then you get further deterioration over time, multiple crashes, stimulatory level, stressful event, body acute stage of decomposition. And then, really, once you get into this part here, once you enter stage 3C over here, down here, but once you get below here, really, it's kind of a very rapid downhill. And death is over here, by the way. 15 is not listed because it's death. Okay, so this is a graphical representation of what's going to happen. And then you have these they stage the adrenal fatigue based on the signs and symptoms. They're going to measure blood glucose, liver enzymes, things like that. They might also measure your ACTH, measure some other things. But you can see that you enter this acute state of decomposition and you kind of die. Severe fatigue, heart palpitations, hypoglycemia, low blood sugar, low blood pressure, insomnia, joint pain, etc. Okay? And then you get little stressors. Once you get into the symptomatic range, when you have little stressors, what's going to happen is you're going to decompensate pretty fast and go downhill much faster. So, I just wanted to show you that. And you have in your notes what's going on at each step. and you will eventually die from heart and kidney infection or overwhelming infection. Okay, so that is, oh yeah, that's our thing. That is the general adaptation syndrome. Thank you for listening. I will see you in class on Tuesday. Have a good weekend.